In section 7.2, we're going to study triangles. A triangle is an example of a closed geometric figure. And what we mean by that is you can start at one point, trace out the entire figure, and finish at any point where you started without lifting your pencil or pen off the paper. So triangles are one example of a closed figure. Starting at this point, I can trace out the entire triangle and finish off where I started. So this is an example of a closed geometric figure. If I have a geometric shape like this, however, this would be an example of a non-closed figure. Another way you can think of a closed geometric figure is it can divide the plane into two different regions. You have the inside, or the interior of the region, and the exterior. Here, if you look at this non-closed figure, the plane is not divided at all. You just have one real region. A triangle is a closed geometric figure that has three sides and also three angles. We will classify the triangles according to sides. A triangle that has two sides of the same length is called an isosceles triangle. If all three sides have the same measurements, then it's called an equilateral triangle. And if no sides have the same length, then it's called a scalene triangle. We can also classify triangles according to the angles. If all of the angles have a measurement less than 90 degrees, then the triangle is called an acute triangle. Any triangle that has exactly one right angle is called a right triangle. And if the triangle has an angle that measures more than 90 degrees, then it's called an obtuse triangle. Let's take a look at the examples below. We want to classify each type of triangle. In triangle A, we see that it has a 120-degree angle. That's an obtuse angle. So this would be an obtuse triangle. In part B, we see that all of the sides have the same measurement, which is indicated by the same dash over each side. So if all three sides are equal, we call that an equilateral triangle. And in part C, we see the right angle marker. So this would be a right triangle. One of the important results as it pertains to a triangle is that the sum of the interior angles of a triangle always add up to 180. To see why this is the case, suppose you have a triangle and you rip it into three pieces. Okay? So if you kind of make cuts along the sides like this, so you can separate it into a few pieces, and you can do so in a way that will allow you to align angles A, B, and C together, like this. And what we will see is that those three angles together would make a straight angle. And we know that a straight angle is one that measures 180. Therefore, the sum of the interior angles in a triangle forms 180. We can use this knowledge to solve for a missing angle. For example, if we want to solve for angle C in this configuration, we know that the sum of the interior angles has to add up to 180. So x plus 40 has to equal 180. This means that x plus 80 equals 180. Subtract 80 from both sides, and we see that x equals 100 degrees. So the measure of angle C is equal to 100 degrees. A very important theorem that's specific to right triangles is called the Pythagorean theorem. The Pythagorean theorem gives the relationship between the lengths of the sides in a right triangle. More specifically, the Pythagorean theorem says that the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. Okay. In a right triangle, the two legs are the ones that form the right angle. So if I look at this triangle, side A and side B, these are the ones that form the right angle. So those are called the legs. If you look at the right angle marker, it almost kind of points towards the third side, which is the longest side of the triangle. That's the one that we call the hypotenuse. Typically, in diagramming and labeling a Pythagorean triangle, we always call the legs either A or B. It doesn't matter which one you call which. And we reserve C for the hypotenuse. So some of you might have memorized the Pythagorean theorem. It's A squared plus B squared equals to C squared. Again, the sum of the squares of the legs are added together on one side of the triangle to be on one side of the equation, and the square of the hypotenuse goes on the other side of the equation. Let's use the Pythagorean theorem to solve for the length of the missing side. So again, according to Pythagorean theorem, the sum of the squares of the legs, A squared plus B squared equals to C squared. Here we don't know the leg A, so let me call that A. We know that one leg is 24. And the hypotenuse here is 30. To solve for A, we need to follow the rules of algebra. We can first do exponents and square each of those numbers. If you do 24 squared, that means 24 times 24. That's going to be 576. 30 squared is 900. We now need to get the A variable by itself. So you would subtract 576 from both sides. This would tell us that A squared is equal to 324. And now we have one more step that's new to this section to solve for A. What's going on with A is being raised to the second power. The opposite of doing a second power is actually doing a square root. So to solve for A, we would need to do the square root of both sides. So A is going to be equal to the square root of 324. That is, we're looking for what number do we have to multiply by itself to get 324. You can use a calculator for this, but it's going to be 18. So the length of the missing leg is 18. We kind of have a follow-up question. Why does the hypotenuse have to be the longest side in any right triangle? An easy way to think about this is if you have a right triangle, okay, we know that one side has to be one angle has to be 90 degrees, and the side that's opposite that is going to be the hypotenuse. All of the angles together have to add up to 180. And if you take away the 90 that accounts for the hypotenuse, for the hypotenuse angle, then that means that the other two angles, the other two acute angles themselves have to add up to 90, which means that individually, each one must be less than 90 degrees. And if you kind of think about like the opening here, the larger the angle you have, okay, the bigger or the larger the corresponding side is going to be. So because the hypotenuse is across from the largest angle, that's what makes it the largest side. In part C, we're asked which of the following triangles is right. So a triangle will be right if it satisfies the Pythagorean theorem. So to check this, let's take the sum of the squares of the smaller two sides, and we want to see, does that equal the square of the larger side? So for the first triangle, I take the two smaller values, the 10 and the 8. This will give me 100 plus 64. So that's going to be 164. 13 squared is 169. And because the sum of the smaller two sides is not equal to the square of the larger side, that means the first triangle is not a right triangle. Let's take a look at the example for the next one. If I do 4 squared plus 5 squared, those are the larger values. We want to check, does this equal to the square of the square root of 41? Well, this is going to be 16 plus 25. The square root of 41 squared is 41. And we get 41 does equal to 41. So this triangle here, it does satisfy the Pythagorean theorem. So yes, this one would be a right triangle. And the way that we checked it is you do the sum of the squares of the smaller two sides. If that equals the square of the larger side, then it is a right triangle. Let's take a look at example 4. They say to build the frame for the roof of a shed, a carpenter must cut a 2x4 to fit the diagonal. If the length of the horizontal beam is 12 feet, so it's 12 feet, and the height is 3, and they're going to cut it, what is the length of the diagonal of the beam? When they make this cut is going to be a perpendicular cut, which means that this is going to be a right angle, which is going to create a right triangle. If it's a right triangle, we know the Pythagorean theorem holds. A squared plus b squared equals to c squared. Here, we're trying to solve for the hypotenuse of this, so our unknown is going to be c. We would get 3 squared plus 6 squared equals to c squared. 3 squared is 9. 6 squared is 36. Is equal to c squared. 9 and 36 make 45. So c squared equals to 45. To get c by itself, we need to remove that square, which means we have to do the square root of both sides. This will give us c equals the square root of 45, which is not a perfect square, but we can get approximate value using our calculator. If we do the square root of 45, it's going to come out to approximately 6.71, and that's going to be feet. 6.71 feet. The next concept we're going to talk about is that of similar triangles. Two triangles that have the same shape but not necessarily the same size are called similar triangles. So if we look at this triangle here, ABC, and compare it to triangle A prime, B prime, and C prime, obviously this triangle is smaller than that one, but the ratios and the proportions and the overall shape looks to be the same, other than just one's larger than the others. Okay? And we call that similarity. One of the ways to show that two triangles are similar is if they have equal angles. So if the three angles in this triangle are the same as the three angles in this triangle, then that would be enough to show that the two triangles are similar, meaning they have the same overall shape. So angle A would measure the same as A prime, B would measure the same as B prime, and C would measure the same as C prime. What's important when we try to utilize similar triangles is that the ratios of corresponding sides will be equal. So the ratio of the length of side AB to A prime B is going to be 1/3. The ratio of side AC to A prime C prime is also 1/3. And the ratio of side BC to B prime C prime is also going to be 1/3. So in similar triangles, corresponding sides always have the same ratio. For example, in question A, it says if two triangles are similar, find the length of side BC. Well, we know the length of side AB, and we know the length of side BC. If that's the same ratio, so the ratio here of AB to A prime B prime should be the same as the ratio of BC to B prime C prime. We know AB is 8. We know A prime B prime is 6. We know BC is 12. And we don't know B prime C prime, so let's call that X. If we set this up, we get a proportion just like we did in the last chapter. We can solve this by cross multiplying. We do 8 times X is 8X. 12 times 6 is 72. And to get the X by itself, divide both sides by 8. And we would find that the measurement of B prime C prime would be 9 inches. If they want us to describe the relationship between the sizes of the two triangles, you can simply just look at the ratio of one pair of sides. So the bigger triangle would have a ratio of 8 to 6 compared to the smaller triangle, or we could simplify this ratio in 4 to 3. So we would say that the two triangles are in a ratio of 4 to 3. Let's look at another example. We want to use similar triangles to find the length of the sides of a tree. So we want to explain why two triangles in the diagram are the same. If we look at light at a particular point in time, so if the sun is at the same point in the sky when these measurements are being observed, then the angle of elevation from the person to the sun would be the same angle of elevation as the tree to the sun. And if the person's standing up nice and tall, then this is going to create a right angle. This one too will create a right angle. And if this angle is equal to this angle, and this angle is equal to this angle, then that means that the two remaining angles in those triangles must also be equal. So because these triangles have equal measured angles, that means that they are going to be similar to each other. We can now use this to find the height of the tree. Just be a little bit careful though with the units here. Okay. So we know that this side of this triangle corresponds to this side of that triangle. So we could say that 5 feet is to 12 feet as, and now we come over here, this person's height is given in terms of 5 feet 10 inches. We don't want to have mixed units here, so we can call this 5 feet, and then 10 inches is the same thing as 10/12 of a foot, as it would be to the height of the tree, which is going to be X. We can now cross multiply to solve the proportion. 5 times X is 5X. We would then need to take 12 times the mixed number 5 and 10/12. That would give us 70. And then divide both sides by 5. And we would get X equals 14 feet. So the length of that tree is going to be 14